Now, what if we have a ball that is located or moved in more than one direction? So before we were talking about a ball that is moving either right or left. Life was easy. We apply the previous equation, displacement equal final position minus initial position, then you will find the displacement. What if the ball is moving as well, up and down in this case? And by the way, this is the Cartesian coordinates in case you don't know it. Cartesian is basically represented the horizontal and the vertical motion of the object in this case. The easiest way to imagine it is the direction coordinates. So you have east and west, and you have south and north. So you have horizontal motion in simplest form and vertical motion. In mathematical terms, we call the horizontal axis as the x-axis, and we call the vertical axis as the y-axis. So the ball moved along the x-axis and it moved as well along the y-axis. And when you project those numbers, you will be able to tell how did the ball move. Okay, now we know how the ball moved, but how to calculate the displacement for the ball? Then we need to use equations to make our life easier than always doing visual. Of course, here visual, we can say, okay, the ball moved on the horizontal axis or the x-axis. It moved 1, 2, 3, 4 units. That's almost where the ball is located. So the ball moved 4 units to the right, and on the vertical axis, it moved 1, 2, 3 units in the vertical direction. So in this case, the ball moved 4 units to the right and 3 units going up in the vertical direction. Now, how are we gonna find the total displacement for the ball in this case? So we have 2D or two directional displacement equations. 2D always refers to directional. I believe your generation, you are familiar with the 2D, 3D from all the technological advancement that you have. 2D means two directional, 3D means three directional motion. So we have, firstly, we have horizontal equation similar to the S equation that we used. This will describe the horizontal motion of the object in this case. And as you see, since the horizontal represents x-axis, so we can see delta means the difference of x, or the difference of the object location, equals object location final minus the object location initial. So initial object location minus final object location will give you the horizontal displacement of that object. Same thing as S equal S final minus SO or S initial. Same as D equal D final minus D initial. The new thing here is the vertical. Since the vertical is represented in y-axis, so we can say delta y equals, or the difference in y in the location of the object on y, equals the y final minus the y initial. So you find the y final minus y initial, and that would give you the vertical displacement of that object. When you finish finding the horizontal displacement and the vertical displacement, you are ready to find the two directional displacement, or the total displacement of the golf ball in this case. Total displacement S equals the square root of delta x squared. So whatever value you found over here, you can plug it in the equation here, and you square it, plus delta y, whatever value you found from doing these calculations, plug it in here, squared, will give you the final displacement, or the two directional displacement of the object. If we use those equations with the golf ball, so we can start with delta x equals x final minus x initial. That means, so on the x-axis, how did the ball move? Let's say the ball started here. That's what we are assuming in this example. The ball started at 0, and moved 4 units to the right. So the x final is 4 and the x initial is 0. In this case, 4 minus 0 equals 4 meters. And for the delta y, the motion of the ball on the y-axis, the ball started from here. So y initial or y0 equals 0. And the y final equals 3. In this case, y final minus y initial would give you 3 minus 0 equals 3. So now we know our delta x and we know our delta y. So what's the s in this case? S, as we learned seconds ago, is the square root of delta x squared plus delta y squared equals the square root of delta x squared is 4 squared plus 3 squared, which means that is the square root of 16 plus 9, which equals the square root of 25, which equals 5, and the units are meters. If you're wondering how, mathematical wise, how did they come up with this equation? So if you draw a line between the location of the ball all the way to here, this is forming, so x-axis and y-axis coordinates over here, they are forming a right triangle. Using the Pythagoras equation, you need to find the distance of this line over here, which equals 5 meters. So the ball moved from origin 5 meters. Now if we take a live example, we have here a hockey field. We have a hockey player over here. The hockey player is at the origin point, which is the origin point of the field. Now he's performing a motion, and we know what is the width and the length of the field. So if the player moved 25 meters from the origin point, so in this case, how you describe the displacement of the player? So the displacement of the player visually you can say is 25 meters to the right. But if you want to use the equation, in this case he's only moving in the x-axis. He's not doing any motion to the y-axis. So you can say S equals S final minus SO or S0 or S initial. So he was at 0, that's the S initial. The final was 25 meters away from origin, minus the origin, which is 0. That equals 25 meters of displacement on the x-axis. Something to think about when you sit alone. What if you want to describe a ball in a room? In this case, we have a cube. There's a ball in it. Assume this is a big ball or even a regular ball in your room. You know what is the width and the length and the height of your room. Then how would you define the two-directional displacement of this ball? Of course, if you grade the room, then you measure. So you have here x-axis, just giving you hints, I'm not gonna solve it. You have here y-axis, and you have here the z-axis. So how far is the ball from origin, or what was the displacement of the ball? That's all about displacement for now. Stay tuned for the next topic. Thank you.